Good morning. Today we'll be looking at the multiplication of a vector by a scalar. A scalar is just a number. As well as another little look at the negative vector and also a look at proving that vectors are parallel. So a vector u, which is multiplied by a scalar, k is just a number that is greater than 0, so a positive number. So a vector multiplied by a number, a scalar, will give the result k times the vector u. This vector will be k times as long, its magnitude will be k times the magnitude of u. Very simply put, look at vector a here. If we multiply that by a number, say number 3 times the vector a would look like that. It would simply be the same vector but 3 times as long, going in exactly the same direction. Vector v, which is ab, multiplied by a scalar k, would be k times a and k times b. And we also know it would be parallel to vector v, because they're going in exactly the same direction, but just k times as long. So here we have vector v and kv, which is exactly the same direction, but just multiplied by whatever the k is supposed to represent. If the multiplier is a negative, that means that the vector will be going in the opposite direction to the original vector. So here we have vector u. And if we want to multiply it not just by 3u, but by negative 3u, it simply means that it's now going to be going in the opposite direction. So here we have vector u going from there to there, but 3u is going from there to there. 3 times bigger, but notice the arrows are pointing in the opposite direction. Each component is multiplied by that scalar. That scalar is just a number. So u being equal to ab, ku be equal to ka, and kb. A negative of a vector is a vector multiplied by negative 1. Now we've looked at this already. If we write a vector as a directed line segment AB, remember that means that we have a line that starts at A and finishes at B. So negative AB would therefore be the line AB going in the opposite direction, so that would therefore be a line starting at B and finishing at A. We can see this visually here. Here we have the vector A to B. We call it AB. But if we were to reverse the direction of that vector, make it the negative equivalent, it would therefore be a vector going from A, not going from A to B, but going from B to A in the opposite direction. So the negative of AB, which we can call negative AB, could also be named BA because it would be starting at B and going to A in that direction. Given u is equal to 1, 5, find 3u. 3u would be equal to simply 3 times each of the components. So 3 times the 1, 3 times the 5. You don't even need to write out that middle part there. 3u is equal to 3 and 15. This is a little bit new. Explain why A is equal to 3 and negative 4 is parallel to B, which is equal to 6 and negative 8. Now, remember, if we can show that one vector is a multiple of the other, if one vector is 2 times the other vector or 3 times the other vector or even a half of the other vector, then that means that they are parallel vectors going in exactly the same direction, but just maybe 2 or 3 times longer. And if you look at the numbers that we have here, we can see that there is a connection with these numbers. I can see, looking at the two top numbers, that 6 is actually 2 times 3 and negative 8 is actually 2 times negative 4. So we can write that out by looking at this. So A is equal to 3 and negative 4, and B is actually double those numbers. B would be 2 times the 3 and 2 times the negative 4, because that would give you the 6 and the negative 8. So therefore we can write that as B is equal to 2 times A. Therefore A and B are parallel. You could have written it the other way as well and written it that A is equal to half of B. That would have been exactly the same thing. And from that you could have also stated that A and B are parallel. Okay, and that's us for today and tomorrow. So exercise 13E, look at the selected questions, and as usual, message your teachers if you have any questions or anything you're unsure of. Okay, and take care and good luck. Bye.